various methods to handle the deadlock situation. Basically there are 4 important methods which are used to handle the deadlock. The methods are deadlock ignorance, deadlock prevention, deadlock avoidance, and deadlock detection and recovery. The first method is deadlock ignorance, which is also known as ostrich method. Now if we when we hear the method deadlock ignorance, the method says just ignore the deadlock. So isn't it funny ki like when the deadlock situation is occurring, we are simply ignoring the deadlock. But yes, our majority of the operating system like your Windows and Linux both use this strategy, that is deadlock ignorance, and it is used widely. So what is in there in the deadlock ignorance means when the deadlock occurs in the system, simply ignore it. And this is faced by near about all of the users, they face in their laptops. The problem is what? Ki your system will get halt, mean the system will get hang, and what we do? We simply power off and we restart the system. So that is what the meaning of the deadlock ignorance. The funda behind it is ki why we are not creating some algorithms to remove the deadlock and all. The funda is ki deadlock occurs very rare. The programmer thinks ki deadlock occur very rare, like once in a 5 years or once in a 10 years. So why we write a full-fledged code to remove the deadlock situation, which will affect the performance. Means like whatever the operating system we use, whatever the operating system, like let's say Windows operating system. So Windows operating system already has a lot of code in this. Like Windows operating system, just like in the normal operating system, it does memory management, resources, resource manager, lot of things operating system does. Other than this, if we increase one more code related to handling the deadlock, removing the deadlock, the performance will be affected. Means performance of the system will get affected over there. So we just want the speed. We want the speed. So speed, just to have more and more speed, what we do, we are not writing the code to remove the deadlock in the situation. So what we are doing, what the programmers are doing, they are not writing any patch, they are not writing any code to remove the deadlock. Why? Because they think it occurs rare. So just for the rare occurrence, they are not writing any code for removing of the deadlock. So what is the advantage we are getting in this? Means the operating system, whatever the major task of the operating system is doing that task only. Means we are not increasing the functionality of the operating system. Ki yes, our operating system is also capable to remove the deadlock. If we try to do this, means if we try to increase the capability of the operating system, definitely it will affect the performance, speed. Means if we are trying to provide more and more functionalities, the speed will be getting less. But nowadays we are totally into the speed. We are not talking about the correctness. Means okay, no problem, 1 or 2 problems occur, but these problem occurs very rare. So just for the rare occurrence of this problem, the simple method is ignore the deadlock. So what we do, we just restart the systems. So this is the meaning of the deadlock ignorance, and this is the widely used technique. And from where we actually use this method, that is the ostrich. Ostrich is a bird. What it does, whenever there is a sandstorm, it just put his neck into the sand. Means it just simply say ki there is no sandstorm. So means it is trying to ignore the sandstorm. So same what we are doing in the deadlock ignorance, whenever there is a deadlock situation occurs, we are simply ignoring that. So that is the simple concept of the deadlock. And why we are ignoring? Because we don't want to affect the performance, or we can say speed. So there is a kind of trade-off between one set of programmers which says ki no, I am not writing any code for the deadlock. If we write the code for the deadlock, the system will get more and more functionalities. So just for getting more and more functionalities, the speed, the performance will degrade. the performance will be getting degraded. But one set of person says ki no, we should write the code for that. But as if we talk about the users, normal users, we are all concerned with more with the speed. We want speed in our laptops, in our systems. But correctness, yes, we want the correctness also, but that kind of correctness or that kind of situation which occurs daily, for that we need the correctness. But deadlock situation doesn't occur daily. Our system is already capable of, like, memory is enough, we are having the CPU is enough, the capabilities are enough, but still if the deadlock occurs, which is rare, which is very rare, so no problem, we are simply ignoring that. So just because of the rare occurrence, we are simply ignoring the deadlock situation. This is the simple meaning of the deadlock ignorance. And Windows, Linux operating system, they use the deadlock ignorance method. The second method is deadlock prevention. The concept of deadlock prevention is like a normal, the very important phrase is ki prevention is better than cure. The method is ki the time when the deadlock occurs, we are trying to find the solution. Better is ki before the deadlock occur, we try to find some solutions. So what are the solutions we can do, or what are the preventions we can do? The main preventions are whatever the 4 conditions, like 4 conditions, necessary conditions. The necessary conditions are, I am just writing, mutual exclusion, no preemption, hold and wait, and circular wait. As we know, these 4 conditions are mandatory conditions or necessary conditions to have deadlock in the system. So what deadlock prevention says, either try to remove all the 4 necessary conditions from the system, or at least try to remove or discard one of the condition. Means we try to simply false one of the situation. Means if all the situations are true, then there is a deadlock. But if one of the situation, means one of the condition get false, the deadlock will be prevented. So this is the meaning of the deadlock prevention. Any of the 4 or all 4, we try to make it false. If any of the situation get false, the deadlock will be prevented. This is the simple concept of the deadlock prevention. Like mutual exclusion. What is a mutual exclusion? Simple method is ki whatever the resources we are using, they should be non-shareable. They should be non-shareable, means they should not be used at the same time by multiple processes. If it happens, deadlock will not occur. So what we do in the mutual exclusion, every process, every resource will be used by one process at a time. So if we false this situation, if we try to false this condition, the deadlock will be removed. Means if I say, let's say CPU, if I make my system like that, ki no problem, CPU can be shared by more than 2 to 3 processes, then what is the need of the deadlock? Obviously the deadlock will be removed in this situation. But there is a problem in the mutual exclusion also. Means not all the resources can be made as a non-shareable, shareable. Means let's say printer. If I want to remove the mutual exclusion, what we have to do? We have to make all the resources shareable. So deadlock prevention mein, the first condition is the mutual exclusion. We try to make it false. False means, how we can make the mutual exclusion false? We can simply say all the resources can be shareable. Means at a time multiple resources can share the resource. If it is possible, deadlock will be prevented. But how it can be possible for printer? How it can be possible for tape drive? Because some of the resources are made like that which cannot be made as a non-shareable, which cannot be made as a shareable. They are non-shareable. Means printer cannot be made as a shareable. It is always a non-shareable. So in this situation, this condition will get, it is very hard to make it false. Although we can make it false for some of the resource like CPU, memory and all, but there are some of the resources which cannot be made as a shareable. उनको shareable बनाया ही नहीं जा सकता, like printer, tape drives. So when it cannot be a shareable, how we can remove the mutual exclusion? Mutual exclusion cannot be removed. So if it is cannot be removed, the deadlock cannot be prevented. Fine. So this is the main point in the mutual exclusion. But yes, if all the resources can be shareable, the deadlock will never occur. So there will be prevention in the deadlock. Second, no preemption. No preemption means if a process is going on, another process is going on, I will try to preempt one of the process. So when the process will be preempted, whatever the resource it is holding, it will be given to another process. Let's say, I'm just making the diagram. We have already seen this diagram many times. Let's say there is one resource of R1 which is taken by P1 and R2 resource is taken by P2 and P2 is requesting for R1. This is a simple method representation. R1 is taken by P1 requesting for R2. R2 is taken by P2 requesting for R1. Now in this method, if I try to make, let's say P1 get preempted, I simply say कि P1 you just preempt. If the P1 got preempted, means it will stop working, it will be sent back to the ready state mein it will be given. So from the running it will be sent to the ready state. So when it's sent to the ready state, whatever it is holding, क्या hold किया P1 ने? P1 is holding R1. This R1 will be taken back. Means I will simply take back R1 from P1 because P1 is not existing. And we can simply say just remove the P1 if it is preempted. Because in the preemption we are trying to switch. Means P1 will be switched, it will be given back to the ready state and P2 will start running. So in this situation, P2 already has R2, P2 needs only R1 and R1 is free. So if the process is free, if the resource is free, give it simply. So I will give this resource to P2. Now P2 can successfully execute. So what we are trying to do, we are trying to make the preemption. Means processes can be preempted. So how we can do it? By using the time quantum, kind of, or timestamp kind of. We use the timestamp method or time quantum method. Means a process can run for this particular timestamp, 5 seconds, 10 seconds. After that particular time it will be preempted. So when it got preempted, the resources will be taken back and it will be given to some other process, and that process will use them and it will be removed. So when it is gone, means there is no deadlock. So we are trying to prevent by making the no preemption to only preemption. And in the first, we are trying to make the deadlock prevention from mutual exclusion to no mutual exclusion. Although it is not easy to make it, but yes, this is a method. So in the second, preemption, no preemption, say we are trying to make it preemption. Means preemption is allowed. If the preemption is allowed, deadlock will be prevented. Third, hold and wait. Again, we are trying to negate it. We are trying to false it. Means there should be no hold and wait. How to make it no hold and wait? What we are trying to do? If the process comes, process says, I need 3 resources. What we will do, before the process gets start, I will give all the resources to that particular process. Means before a process gets started, whatever it is demanding, I will simply provide all the resources to that particular process. Although it is practically very impossible to do it, because I cannot give the resources simply to a one process. Other process will be totally waiting for any of the resources. But still, this is a kind of method, so we are just following this method. Means rather than a process holding some resource, waiting some other resource, what we are saying, you just hold all the process, all the resources you need. We will simply give all the resources what it needs before it gets started. So when it get all the resources, after some time it will get executed. When it get execute, means there is no deadlock, because the resources will be free, it will be given to some other process. So what we are trying to do, hold and wait ki bajaye, we are trying to do no hold and wait. Now the fourth one is circular wait. For deadlock there must be a circular wait, but to remove the circular wait means if we want the deadlock should be prevented, there should not be the circular wait, means we are trying to remove the condition of circular wait from the system. So how we are trying to remove it? The simple method is, let's say I am having lots of resources in my system. So this method says ki how we can remove the circular wait condition. Just give the numbering, just order all the resources, means if we want there should be no circular wait in my system. What we are trying to do, we are giving the numbering. Let's say I am having printer, scanner, CPU, let's say register, various resources we have. What we are trying to give, we are trying to give the numbering. Simple, just give the numbering to all the resources. And the condition is कि whenever a process is requesting for a resource, it will request in the increasing order. Means if a process P1 comes, P1 says, let me make the diagram. Let's say if P1 comes, P1 says I need one, means printer, means I need one printer. So printer means one, let's say resource 1. So it has taken printer, that is the resource number 1, numbering 1, that is printer. Now it can request for 2, 3, 4, means in the increasing order. Let's say now it wants CPU. So it can request for CPU? Yes, it can request for resource number 3, that is CPU. What is the resource number 3? CPU. What is the resource number 1? Let's say printer. It's coming. Let's say CPU and let's say printer. Now if the other process comes, let's say now P2 comes. P2, a process. The main line is what? A process can request in increasing order. This is the simple meaning. A process can request only in the increasing order. Means if the order is increasing, then only it can request. Means if P2 comes, P2 says I need CPU, means I need the resource number 3. No problem, I can give the resource number 3 to P2. Now P2 says I need resource number 2 or I need resource number 1, means the number which is less than the it already have. The number which is less. No, a process cannot request for the number less than the previous request. Means now if the P2 says I need the number 1 resource, no, it cannot request. This request cannot be made. If this request cannot be made, we can simply say there is no circular wait, because this line is there, this is there, this is there, but this line cannot be made. This line cannot be made. But can we say कि P2 can request for resource number 4? Yes, P2 can request for the resource number which is greater than the previous request, because P2 has already requested for the resource number 3, that is CPU. So I just simply gave it. Now P2 says I need the resource number 1. So 1 is less than the 3. No, the previous request must be greater than. the current request. So yes, previous request is 3. Now the P2 says I need resource number 1. No, the request number cannot be less. So a process, the simple meaning is a process can request for a resource in the increasing order only. Means if a process says I need the resource number 3, no problem, it can have 3. Next time it can request for 4, 5, 6, not the lower one. By doing this, we will simply removing the circular wait condition. So when the circular wait condition will be removed, we can simply say deadlock will be prevented. This is the simple meaning. Next is the deadlock avoidance. What is the concept of deadlock avoidance? Means we are trying to give the resources to the process, and whenever we give the resource to the process, we will check whether it is a safe situation or not. Means when we give the resources to a particular process, we check whether deadlock can be occur or not, or deadlock can be avoided or not. For every resource allocation, we check the safe or unsafe situation. This is done by the Banker's algorithm. Dijkstra's algorithm is also known as this. Banker's algorithm is given by the Dijkstra, that is the scientist. So Banker's algorithm resolves this problem, that is the deadlock avoidance. So for getting more details of Banker algorithm, you can follow my video on Banker's algorithm. Next one is deadlock detection and recovery. What is the concept of deadlock detection and recovery is, deadlock detection means we are trying to detect, like by making the resource allocation graph or other methods, we are trying to detect first whether there is a deadlock or not. And when we detect it, then we are trying to recover our system. So that is also a kind of little complex, because deadlock detection is also complex, and after detection we are trying to recover also. So it will make the system again very complex. So what is the concept says? First of all, we are trying to detect. After detection, if say there is no deadlock, so nothing, we don't need to do anything. But if there is a deadlock, we are trying to do some recovery. Recovery simply says, let's say one method is kill the process. Kill the processes. Kill the processes or a process. Means just simply kill, like whatever the processes which are in the deadlock situation, let's say 2 to 3 processes are in the deadlock situation. Either we try to kill one of the process, and then we will check again, that we will again detect that there is still deadlock or not. If there is no deadlock, no problem. If there is still deadlock, we will kill one more. We will kill 2. Then we will again detect whether there is a deadlock or not. If it is deadlock, we will kill the third also. Means we are trying to kill all the processes which are in the deadlock situation. So definitely it will hamper the performance of the system also. But that is just a method. Recovery says simply killing the processes one by one. One more thing can be done, resource preemption. Resource preemption means what we are trying to do is we will preempt the resource from a process. Means a process has taken some of the resource, waiting for some other resource. We will preempt the whatever resource it is holding. Although it is again kind of fuzzy method how we can preempt the resource from a process, but still that is just a method, kind of theoretical method. We are trying to simply recover the system from the deadlock by detecting it, and then if there is a deadlock, we are trying to kill some of the processes, let's say lower priority processes, the processes which is having lowest priority, we try to kill them, or we are trying to take the resources back from one of the process or 2 of the process, just to remove the deadlock from the system. So this is what how the various methods which are used. One is a ignorance, prevention, deadlock, avoidance, and detection and recovery. And you will be shocked to know that this method is real life implementation, deadlock ignorance. Although other methods are also implemented, but this is the most and widely used method, that is just the deadlock ignorance. So this is all about the various methods to handle the deadlock. So if you like the video, please share it with your friends and colleagues, and please subscribe my channel. Thank you.